All right, let's dive into something huge today, a totally new way to understand our massively complex world. It's this powerful framework called compositional game theory. And honestly, it has the potential to reshape how we model, well, everything, from the global economy to the future of AI. So, let's get right into it.
But first, just think about this for a second. How on earth do you even begin to make sense of something like the global economy? Or how competing AIs are going to interact with each other? I mean, these are colossal systems. They've got countless moving parts, and every single one influences all the others. It's overwhelming, right? So where do you even start?
Well, the answer might just lie in this new approach, compositional game theory. See, instead of trying to swallow the whole system in one giant bite, it gives us a way to model all those strategic interactions by, you guessed it, breaking everything down into smaller, much more manageable pieces.
And the real secret, the key to this whole thing, is right there in the name, compositional. Now, this isn't just some fancy label. It's a fundamental engineering principle, and it's designed specifically to tackle complexity.
This slide really lays it all out. On the left, you've got your typical monolithic system. Think of it like a giant tangled ball of yarn. It's a complete nightmare to figure out. But on the right, that's a compositional system. It's built from simple, predictable blocks, kind of like Legos. Because you can understand each little block on its own, the whole system suddenly becomes way easier to analyze and manage.
So how does it work in the real world? It's actually a pretty logical step-by-step process. First, you just isolate one single component. Then you work to understand its rules, how it behaves and interacts. Once you've got that piece figured out, you just combine it with other components you already understand. You just keep repeating that process, building from the ground up, until piece by piece you have a working model of the entire system.
Okay, but to build systems like this, to have a really solid set of rules for how to snap all these pieces together, you need more than just a good idea. You need a special kind of language, a formal structure that makes the whole thing possible.
And that language is a field of math that's all about connection and composition, category theory. Now, don't let the name intimidate you. All you really need to know is that it's like a universal grammar for systems. It gives us the exact rules for describing how different parts connect and combine. It's really the fundamental tool that makes this whole thing work.
So this is what's called the categorical view. We basically stop worrying about all the messy details inside each component and just focus on the inputs and outputs. We treat each part of a system like a component that interacts with its environment. This is the core idea behind something called open games, where every piece is like a player in a bigger game, responding to moves from its environment and then making its own moves back.
There's a fantastic word for these kinds of processes, cybernetic. It really gets to the heart of it because it's all about how these components regulate themselves, how they communicate, and how they interact. It's a truly dynamic way of looking at the world.
And this is where things get really fun. It just goes to show how creative this field can be. All this abstract research has led to some wonderfully named concepts, including one you probably weren't expecting, cybernetic kittens. Yep, it's a seriously memorable name for a very serious idea that connects open games with dynamical systems, and it proves that even the most abstract work can have a playful side.
And listen, this isn't some old idea that's been sitting on a shelf. The foundational papers only started popping up around 2016. Then there was a huge wave of research in 2020 and 2021. This is an active, evolving toolkit that scientists and mathematicians are literally building as we speak. So here's the crucial point, the main takeaway. Compositional game theory is not just some abstract idea, it's a practical toolkit. It gives us a brand new lens and a new set of tools to build much, much better models of the complex systems that define our world. Which, of course, leaves us with one final, absolutely fascinating question. Now that we have this incredibly powerful toolkit for building understanding from the ground up, what should we point it at next? Climate change? Social networks? The human brain? The possibilities, they are truly endless.